GATE 2018 Civil Engineering Set 1 question number 44. At a construction site, a contractor plans to make an excavation as shown in the figure. The water level in the adjacent river is at an elevation of 20 meter. Unit weight of water is 10 kilonewton per meter cube. The factor of safety against sand boiling for the proposed excavation is we have to find out. Reference to the relevant NPTEL courses and video has been cited. Now coming to the useful data, to understand the sand boiling, which is also termed as quicksand condition, we need to understand some following terms, which are seepage pressure, and the other term is Cph force, and the third term is specific seepage force. Seepage pressure is the pressure exerted by water over soil skeleton. The formula for seepage pressure, if you want to write, which is seepage pressure is equals to seepage head into gamma W. We know the basic equation or the basic formula which is used for permeability in soil, that is hydraulic gradient I is equals to head loss divided by the total length in which the flow is occurring. So I will simply write total length. So let's say our head loss is delta H and the total length is Z. So head loss, which is also termed as seepage head delta H will be equals to I into Z. So we can write here that PS is equal to seepage head into gamma W. So we can simply write it as I Z gamma W. So this is seepage pressure. And one thing we have to keep in our mind that the seepage pressure always act in the direction of flow, that we have to keep in our mind. Now coming to the seepage force, which is seepage pressure into area, so we can write it as that PS is equal to seepage pressure into area. So it will be I Z gamma W into A. So this is the formula for seepage force. Now specific seepage force will be seepage force divided by volume. So it will be I Z gamma W into area divided by A into Z. So this will cut down. So it will be I into gamma W. So this is specific seepage force. Now coming to the quicksand conditions. To understand the quicksand conditions, we have to understand the effective stress concept first. If flow is vertically downward, the effective stress always increases. So let's say our effective stress is sigma dash. It will be Z gamma submerged plus I Z gamma W. So it is clearly visible that in this case sigma dash, that is effective stress, is increasing, where Z gamma submerged is submerged weight and I Z gamma W is seepage pressure. Now this is first condition. Now let's suppose if flow is vertically upward, in this case effective stress always decreases. So we can write it as sigma dash equals to Z gamma submerged minus I Z gamma W, and here effective stress always decreases. In the first case, if flow is vertically downward, effective stress always increases, and if flow is vertically upward, effective stress always decreases. Now as I have already explained that seepage pressure always act in the direction of flow, and if flow is vertically downward, our effective stress is increasing, and if flow is vertically upward, our effective stress is decreasing. Now what happens in quicksand conditions? Let's say if the flow takes place in upward direction, so as a result seepage pressure will also act in the upward direction, and as a result effective stress will decrease. Let's say a stage comes where submerged weight become equals to seepage pressure. At this stage sigma effective, that is our effective pressure, will reduce to 0, and in such cases cohesionless soil mass loses its shear strength and will have the tendency to flow along with the water. So this phenomena is termed as quicksand conditions. At quicksand condition effective stress will reduce to 0, so that means flow is vertically upward, so we will write Z gamma submerged minus I Z gamma W equals to 0. By this we can write Z gamma submerged will be equals to I Z gamma W. So now if you solve it, we will get I, which is hydraulic gradient, will be equals to gamma submerged divided by gamma W, and we know that critical hydraulic gradient IC is G minus 1 plus E. So to avoid quicksand condition, hydraulic gradient should always be less than critical hydraulic gradient. So this was formula of critical hydraulic gradient. So we can write here factor of safety to avoid quicksand condition or sand boiling will be equals to IC upon I, and it can also be written as submerged weight divided by seepage seepage risk. This is the factor of safety we will use. Normally, as we have mentioned that quicksand conditions occurs in cohesionless soil. These are some examples that in which soil quicksand conditions will occur. It will occur in sand, which is very fine, and it will occur in coarse silt also, but it will not occur in gravel, clay, fine silt, and coarse sand. Now coming to the video solution, elevation of water level given is 20 meter. Unit weight of water is 10 kilonewton per meter cube. Unit weight of clay, this is gamma W, and unit weight of clay gamma given is as 20 kilonewton per meter cube. Now we have to find the factor of safety against sand boiling for the proposed excavation. So we know that the factor of safety is submerged weight divided by seepage pressure. So we can also write it as submerged weight seepage pressure is seepage head into gamma W. So we know that submerged weight will be 10 into gamma submerged, and some seepage head will be 20 minus 10 and into unit weight of water, which is gamma W. So we can write it as 10 into gamma submerged will be 20 minus 10, which is gamma set minus gamma W, and here it will be 10 into 10, so it becomes 10 by 10. So we are getting a factor of safety 1 here. So the factor of safety against sand boiling for the proposed excavation is 1.0. So that is our answer. Reference to the relevant NPTEL courses and videos has been cited.